Good morning, my algebra students. So here we are kind of wrapping up chapter 8. And we're just going to kind of review a little bit of what we've done. We are going to look at quadratic functions, and we've been talking about this for quite some time. But if I look at a quadratic formula, just from a table standpoint, we know linear had a constant change in x and y, right? We knew that if we added something consistently to the x values and we added the same thing to both the x and y values, then we could say that it was linear. So on the x values, you can see, oh, that is linear. On the y values, this is not linear because we're subtracting 6. Then we're subtracting 2. Then we're adding 2. Then we're adding 6. But with a quadratic function, what we see is at the second layer of the y constants, we see that's when there's a consistent change in the y values, when it's the actual second layer of it. So let's just look at graphing some of these functions and what they look like. If I have y equals x squared, I can go ahead and make a table and throw in some numbers. And because it's a quadratic, I need to have -2, -1, 0, 1, 2. And then I can plug in my values. So -2 squared is going to, well, I'm first going to do my vertex, which is always that middle term. And so for this one, it happens to be 0, 0, because we don't have a y-intercept. 1 squared is 1, 2 squared is 2. And that we'll see here is on the other side of the vertex, that 0, 0, that the values will mirror, right? -1 squared is 1, and -2 squared is 4. So when we see this drawn, we can see that the one side mirrors the other. And that's because the middle line down here is called the axis of symmetry. And symmetry means to have one side match the other, right? So people's faces are symmetrical. You have two eyes and things like that. This is the axis of symmetry, and you can see that one side mirrors the other. That these are all equal distance from that line. There's 2 spaces here and 2 spaces there, and so forth. So let's go ahead and graph something with a y-intercept. We'll go ahead and make a table of -2, -1, 0, 1, 2. And we will plug in our values here. Now, if x is 0, then we know y is 4, because 0 plus 4 is 4. And then 1 squared is 1 plus 4 is 5. And 2 squared is 4 plus 4 is 8. And it also mirrors the other way. -1 squared is 1 plus 4 is 5. And -2 squared is 4 plus 4 is 8. And this is what this looks like. You can see it's the exact same image that we had, but there is a y-intercept, right? So if I were to just grab this was what it was at 0, and this is what it is at 4. So it has just transformed going up by 4 spaces. Now, what happens if I have a negative value in front of the x squared? Well, what we should see is that it makes a sad face. Instead of a happy face, it makes a sad face. What do I mean by that? Well, let's go ahead and plug in our values. So when x is 0, y is going to be 0 as well. And then -2 times 1 squared is just going to be -2, and -2 times 2 squared is going to be -8, right? Because 2 squared is 4 times -2 is 8. And then we mirror on the other side. We go ahead and draw this out, and we can see, because it is negative right here, this makes a sad face, right? It makes a sad face. All right. What happens when we have a smaller a value? when I do the math here. 1/4 times 0 is still 0. And 1/4 of 2 is just going to be 1 because it's half of 2, right? And 1/4 of 4 squared, which is 8, which is 16, is going to be 4. And then we mirror. And we see when it is a smaller a value here, it gets wider here. Gets a broader fraction. A broader smile. So we know that if it was to be bigger, we would have, and you can see that with this one right here, how much smaller, how tighter it is because it's a larger number versus a fraction, right? So this shape is called the parabola, and the center of the shape is called the vertex, and it's a very specific point on a graph, and it's an X and Y point on the graph is the vertex, and the line of symmetry is the X value where it crosses the X axis, and the Y value will be the minimum or maximum of these values. You can tell that with a positive like this, that this is the lowest. This is the lowest that this will ever go. So this will always be, the lowest. But if it was going the other way, it would be the highest or the greatest maximum. So if the A value is bigger than 0, it's positive. It opens up, it makes a smiley face. And it has a minimum of, I'd like to say, a minimum of negativity. It just can go so low. So it has a minimum. But if it has a value less than 0, so a negative number, it opens downward, makes a sad face, and it has a maximum amount of positivity, a maximum amount of positive Y values. That's how I like to think of it. So on these, we're going to tell whether the line opens up or down. Go ahead and do this. You try. Look at this, and we can see because it's positive, it's going to open up. This one, it will open down. Give this one a whirl. Yep, you're right. It's positive, so it opens up. So let's talk about the vertex of each parabola and whether it shows a minimum or a maximum. So first we're going to find the exact point on number 1, and we can see that's going to be a vertex of -3, 0. And because this is positive, then it will have a minimum right there, as a minimum of 0. This can never go below 0 on the Y values, ever, right? It can contain all the X's, but it can only go down to 0. It has to be all positive numbers. And the axis of symmetry is -3, because that's the X value. Let's look at this one over here that's obviously going downward. So we first find our vertex value, which is 3, 5. And our maximum, the highest positive Y value we can have is 5. And the axis of symmetry is 3. So you'll want to write this down. The vertex is a specific point, and the X value is the axis of symmetry, and the Y value is the minimum or maximum of those Y values. Go ahead and try this one. You want to decide the vertex and if it has a maximum or minimum and what that would be. All right, so the vertex here is going to be -2, 2. with a maximum of 2, right? Remember, the y value shows whether it's a minimum or maximum. And our axis of symmetry is -2. We're going to skip that part. Now let's talk about the range and domain. When I look at this, I first find my vertex. My vertex here is going to be 2, 1. The domain, all my x values, will always be infinity, right? So are all real numbers. Where my y value, that's the one that will have a limitation. On this, it has a minimum of 1. So I know it can be 1 or greater than 1, right? So it can be 1 or greater than 1. And that's why we say it's equal to or greater than 1. So it can be 1 or bigger than 1. Let's try this one. Okay, let's see how you did. So first we find a vertex of -2, 1. And we know that it will always have all real numbers when it comes to the domain, right? But the range is what's limited. And on this one, it has a maximum of 1. So y can be 1 or less than 1. Okay, let's go ahead and practice this one now. Find your vertex first. And our vertex is 1, 2. Our domain is always all real numbers. And our range has that limit. The lowest it can go is 2. So we'd have to say that y can be equal to or greater than 2. Go ahead and try this one, see how you do. All right. Let's see, did you find that it's all real numbers for domain, that your vertex is -4, 2, and that the range can be equal to or less than 2? Okay, we're going to go ahead and take class time right now to practice this. We have a few word problems on a puzzle that you're going to do with a partner, and then we'll get to our second lesson of 8-2 today.